Welcome to this lecture on digital computer electronics. In this lecture, we are going to discuss about sequential logic circuits. We will talk about the introduction of these circuits, latches or flip-flops of SR and JK types, and finally we'll discuss about the concept of a resistor. Sequential logic circuits. Those logic circuits whose output at any instant of time depends on the present state of inputs as well as the past outputs. These circuits are designed with flip-flops as their basic elements, along with necessary combinational circuits wherever applicable. Registers and counters are the most important and widely used sequential logic circuits. Registers are used for storage and modification of data, whereas counters are used to count the clock pulses coming to their inputs. In the sequential logic, we'll start with the basic circuit, what is called a latch or SR latch. Is a circuit connected with two NAND or NOR gates. So such type of circuit has four conditions according to its input variations. The conditions where S is 1 and R is 0 is known as a set state, and the condition where R is 1 and S is 0 is known as reset condition. And if both S and R are 1, the output Q and Q naught will be not changed, will remain in their previous stage. But one condition, both the inputs are 0, the outputs Q and Q naught are changing chaotic manner. So when the outputs Q and Q naught cannot be determined, this condition is known as race round condition, a condition where exactly the output Q and Q naught are not stable. So this is a SR latch, or we call as SR flip-flop. This latch is considered as a circuit which can log one bit of information, one binary bit of information. If we move towards the other modification of the same latch, we add a stage of two more NAND gates and make it dependent on the clock pulse. So if S and R are fed and the clock is not given, the circuit will not work and the latch will not get any information. So according to this truth table, where the clock is shown that if clock is 0, then S and R will be anything. There will be no change, means whatever was stored previously in the latch, that will remain there. And if then there is clock presence and both inputs are 0, there will be no change, means again it will remain in the same stage, but the changes occur in the 3 configurations when both are 1. It goes to a race condition, race round condition, and if set condition is there, S equal to 1 and R equal to 0, the output is 1, and if the output is 0, only when there is a reset condition, R equal to 1 and S equal to 0. This circuit is level triggered, means if you have 0 means complete 0, and if the level of 0 is changed to 1, a particular voltage, then the output will be possible, or the triggering what we call as is possible. Then we can connect S and R inputs with the help of a NOT gate. Then it will form what we call as a data flip-flop. What is important for this data flip-flop is that we avoid all other conditions of 1 1, where there will be a race round condition, and 0 0, where there is no change. So this type of flip-flop, D for data flip-flop, is used actually to store an information. If D is 1, Q will be 1, means that bit of information will be stored, and if D is 0, the Q will be 0, that means again 0 information is stored. So if you see the truth table of such type of flip-flop or data type flip-flop, is that when clock is 0, there's no change. When clock is 1, there's no change. When clock is going down, there's no change. But when the clock is moving up, and there is 0 at the input, the output will get 0. And in the same way, if the clock is moving high, towards high, if there is 1 at the input, the output will be also 1 in the perfect data type flip-flop. So the other configuration of the latch or flip-flop is JK flip-flop. It's different from SR flip-flop in the one sense that instead of having first stage of 2 input NAND gates, it's having instead 3 input NAND gates. So the third input of the every gate is connected to the outputs as shown. Again, this is an edge triggered flip-flop having the clock connected to RC circuit. If we see the truth table of this type of flip-flop, if clock is 0, no change. If clock is 1, no change. If clock is moving down, no change. If clock is 0 or clock is not present, so 0 0 is there at the inputs. Whatever there is at the input clock, and the clock can be anything, but there will be again no change. So if the clock is moving up, there are three types of changes which occur in this type of flip-flop. For 0 1, a reset. For 1 0, a set. For 1 1, a toggle. What a toggle means is that the output will change from the earlier stage to the other stage. But if we have the J flip-flop, then we connect it to two inputs and make a T flip-flop, means when we'll give 1 at T, the flip-flop will toggle, means that its output will change according to the every clock pulse being given. With every clock pulse, the can get the input, the output will change. The output will change its state from 0 to 1 and 1 to 0. Another type is that if we connect between the inputs, if we connect a NOT gate, then it will turn into a D flip-flop or data flip-flop. Another important flip-flop is master-slave flip-flop, which is designed with the help of two stages of JK flip-flop. In this we have two flip-flops, JK flip-flops, which are connected one after the other. And the clock of the first stage is connected with a NOT gate to the next stage. The first stage of the JK flip-flop is known as master because it controls the operation, and the second is known as slave because it receives what is being given by the master. So this sort of flip-flop is actually used for avoiding the race round conditions. For the race round condition is that the both inputs J and K should not be equal to 0. So that puts the flip-flop into an ambiguous state where the determination of whether the outputs are 0 or 1 is not possible. So they remain changing. So that to avoid that condition, we use such type of flip-flop. When the master is triggered with the clock, master latch stores a bit of data appearing at the input of the slave. But at that stage, the slave is not active due to this NOT clock at its input. And when the clock stops at the master stage, what was at the output of the master or the input of the slave, that will be transferred to the slave stage, and the slave will store that data. So in this way, if anything was coming as a race round condition at the input of the master, it will get stopped there. Next, we'll try to learn about what is the register. A flip-flop, single flip-flop, there's SR flip-flop, JK flip-flop, any other flip-flop, it is actually storing or locking or latching one bit of information. So if a D flip-flop is there and we have 1 or 0 at its input, the flip-flop will store whatever is the value of D. So if such flip-flops are connected in series like this, then it forms a 2-bit register. A single flip-flop is 1-bit register, and 2 flip-flops is a 2-bit data register. So with this, we come to end of this lecture. Thank you very much.